All right, so now we move into lesson 8.2, which is the second lesson of our third unit, which is systems of equations. Now, first and foremost, we want to cover from 8.1 that we had talked about how to solve systems graphically. So we isolated both the equations for y, we plugged them into our graphing calculator, we solved for the intercepts. In this lesson, what we're going to do is start introducing the algebraic methods, primarily elimination and substitution, that can help us take these linear quadratic or quadratic-quadratic systems and then solve for specific solutions. Now, let's just do a quick warm up from our Math 10C. In Math 10C, we dealt with equations that were both linear terms, and we know they're linear because the x had a degree 1, or it was degree 1 because the exponent on x is 1 for both of these. So they're linear functions, they would form some sort of linear line. Now, from here, if we wanted to do the elimination method meant we had to get rid of one of the variables by either adding or subtracting the equations. Now, from both of these, I look at this and I'm like, well, as is, the 3 and the 5 aren't the same. The -4 and the -6 aren't the same. So what we have to use is an LCM, or a lowest common multiple, to make one of them the same so that we can isolate it. So in this situation, we just want to pick one of the variables that we want to eliminate. In this case, maybe we want to eliminate the y's in this situation. Now, if I want to eliminate the y's, I look at this equation here, the original equation, and go, well, -4 and -6, the first number that both 4 and 6 both multiply to is 12. So accordingly, here's what we'll have to do in our elimination here. We're going to take these equations and just rewrite them out. 3x minus 4y is equal to, let's just make sure we get the right number, 7 on the right. And then we had 5x minus 6y is equal to 8. Now, from here, what we have to do is use our LCM. Remember, we said 4 and 6 both multiply to make 12. And so to get to 12 from 4, I have to multiply the top equation all by 3. I have to multiply the bottom equation all by 2. Okay, let's rewrite our new equations. So if we multiply all the terms in the first one by 3, it's going to become 9x minus 12y is equal to 21. In my next equation, it's going to be 5 times 2, which is 10x, minus 12y, which is equal to 8 times 2, which is 16. All right, now as soon as you see that two variables, or one of the set of variables, in this case the y variable, has the exact same term, we now need to decide if we're going to add or subtract these to eliminate those y's. Now, really easy way to determine add or subtract, if they're the same sign, you're going to subtract. So they can be both negative or both positive, you're always going to subtract. If they are opposite signs, you add them together. So in this situation, let's put our negative here, because we want it to be a negative minus the number, which actually causes it to flip to be positive. 9 minus 10 is going to be equal to negative 1x. Realistically, you don't have to put the negative 1, but I'm just going to make sure it's there. Negative 12 minus 12, that turns positive. It becomes 0. And then on the other side, this is going to be equal to 21 minus 16, which is 5. Now, from here, we can divide both sides by the -1 because we want to get rid of the -1 in front of the x, or the negative. This is going to give us x is equal to -5. And so now we have our solution in terms of the x value, but this is only halfway. In Math 10C, we would have called this half a solution. We need the y value. To get the y value, we simply just take this number of x equals -5 and plug it into one of the original equations. So it doesn't really matter which one. I'm going to choose the one with slightly simpler numbers, which is our first equation. So we're then going to go 3 times the -5, or 3 times the x value, minus 4y is equal to 7. From here, this gives us -15 minus 4y is equal to 7. If I add 15 to both sides, which I'll show just right here, plus 15 plus 15, this is going to give me where I have -4y is equal to, and then 7 plus 15, we should get 22. Therefore, if I divide both sides by the -4, dividing both sides by -4, unfortunately, it's not going to give us an even number or an integer value. We're going to divide both of these by 2, and therefore it's going to give us 11 over -2, which you could then rewrite as -11 over 2, just generally where the negative is more out front of the term. That would be totally fine. All right, now I'm just going to slightly clean up this plus 15 on both sides just to make sure that that looks just a touch neater for us. So plus 15 and then plus 15, representing that we did it to both sides. Awesome, there we go. Now we have a solution. Our solution is technically where x equals -5, y is equal to -11 over 2. To verify this, which is one of the steps, when we do these systems of equations, we always want to verify it what we would do is we would plug in our ordered pair of -5 and -11/2 for both of the equations and see if they're both equal, left-hand side equals right-hand side. Now, because of the lack of room here, it makes it a little bit tough, but let's see if we can actually do this here. We're going to try our best to do this. So our solution that we supposedly get is going to be equal to -5 and -11/2. Now, we would highlight this, of course, because we want to hold on to this value. We think that this is the solution that satisfies both equations. To verify it, I'm just going to scroll up and look at both equations. 3x minus 4y minus 7. I'm going to plug in the values right away, our verify. So I'm just going to write it here. Verify step. Awesome. First equation was 3 times the -5, which is the x, minus 4 times -11/2. And then this supposedly equals 7. On the left-hand side of this equation, we're going to write this as -15 minus, well, actually it becomes positive because the double negative, -4 and -11/2. 4 divided by 2 is 2. 2 times 11 is equal to 22 is equal to 7. Yes, we get 7 is equal to 7. Left-hand side equals right-hand side. Perfect. All right, now we're going to verify it for the other equation. Our other equation, if we scroll back up, was 5x minus 6y equals 8. So we're going to plug in the numbers right away. 5 times the -5 minus 6 times the y value, which was -11/2. And this was all supposedly equal to 8. From here, this is going to give us -25 plus, because the double negative, 6 divided by 2 is 3. 3 times 11 is 33. 33 plus -25 should equal to 8. Yes, 8 does equal 8. Therefore, we verified it for both. So this is exactly what it should look like in the end, is you should have your solution, it should be highlighted, but in an algebraic solution, such as a written response, you would want to make sure that you verify it and show that the left-hand side equals the right-hand side in the original equations. Really, really important. Okay, what we're going to do is we've already done the verification one time. So when we go to do our substitution, when we do substitution or elimination, I want you thinking that you're going to expect the same answer. So when we do this and we get to our solution, it should be -5 and -11/2 because substitution is just the other algebraic method of solving systems. And then for our verification, we're just going to copy and paste it over on the right-hand side because the verification should be the exact same. They're both the original same equations, so we should be good with that. Now, using substitution, what we have to do is we have to pick one of these equations here, one of the starting ones, and we have to isolate it for one of the variables. So let's say I chose that I wanted to isolate the y value on this top equation. Well, let's start by writing this out. It's going to be 3x minus 4y is equal to 7. Now, I'm going to subtract 3 from both sides, and I'll make sure I do that in a different color here. So minus 3x from both sides. This is going to give us -4y is equal to -3x plus 7, because the 7 was positive over on the right. We're then going to divide both sides by -4. When we divide both sides by -4, it divides to both of the terms, and therefore my isolated y value is going to be 3x over 4, because it becomes positive, negative over negative. The 7 over -4 is going to become -7 over 4. And all I'm doing is just separating these into their own terms here. Realistically, I could keep it all together as a bundle, but I like separating it like this. Okay, we have our y isolated. Now we're going to take all of what y is equal to and plug it into the y of the second equation. So if that was step number 1, step number 2, we're going to write it as 5x minus 6 times everything that we saw above here, representing the y, is going to go down in the bracket here. This is going to be 3x over 4 minus 7 over 4 goes into the bracket for y. It's all equal to 8. Let's just tidy that up just a tiny bit there. There we go. And then my 8s sometimes look a little rough, so I'm going to make sure those are good. There we go. So now we have 5x minus 6 over 4 is -3 over 2. If we have 3 over 2 multiplied to, it might even be better just to multiply 6 times 3, which is 18. 18 over 4 is the reduced fraction. Actually, let's go the other way. So if we do 6 divided by 4, this is going to give us 3 over 2. 3 times 3 is 9, so this should reduce to 9x over 4, or 9x over 2, I should say. Now, -6 times -7 over 4, negative times negative is going to give us a positive value. And then in terms of 6 over 4, again, this gives us 3 over 2. And then 3 times 7 is going to be 21 over the 2 that was the divisor, or the divisible factor here. Now this is equal to 8. Okay, perfect. Now, what we want to do is we want to combine these things together. If we want to combine these things together, first and foremost, 5x minus 9x over 2, 5x, if I wanted to make this into a fraction of 2, we need to make sure that this is a multiplication factor that causes this to go to 10x over the 2 in this case. There we go. So because if we want to create this common denominator, we have to multiply top and bottom by 2. This is going to be minus 9x over 2. And then for my second term here, if we move it to the other side, and this becomes 8 minus the 21 over 2 like this, then what we're going to have to do is we're going to simplify our left-hand side. 10x minus 9x is equal to 1x, or x divided by 2, which is equal to, on the other side, if I want 8 to become something divided by 2, it must be something like 16 over 2. Because if we want to get back to 8, so this would become 16 over 2 minus 21 over 2. This will give us x over 2 is equal to 16 minus 21 is negative 5 over 2. And then we're going to multiply both equations by 2 in order to isolate for x. Therefore, we're going to get x is equal to negative 5 over 2 times 2. This just leaves us with negative 5. Hey, look at that. We get that same negative 5 that we got in our elimination method. Perfect. This is exactly what we're looking for here. Now, in order to solve for the y value, in the substitution method, I really like this because we can take that x value we isolated and then plug it into our isolated y equation that we did in our step 1. So step 1, we isolated a variable, we then substituted it in. Nice thing is, once you solve for that first variable, you can just go right back to step number 1. So I'm going to plug in negative 5 to all of that here. So we have y is equal to, and just to make sure I get my numbers right, it's going to be 3 times x, which is 3 times negative 5, all over 4. And then it should be minus the 7 over 4, just to make sure I'm getting my numbers right. This is going to give us y is equal to, there we go, y is equal to 3 times negative 5 is negative 15 over 4 minus 7 over 4. This gives us negative 22 over 4, which when we then note both of them divide by 2 and it gives us negative 11 over 2. Hey, look at that. We get the exact same y that we got on our previous step. So therefore, the solution is actually just the exact same, and then our verification step would apply for both. And so what I'm going to do is I'm going to say at this point, I'm just going to go right below here and say, therefore, we have this where our solution is negative 5 and negative 11 over 2, just like it was before. I'm going to highlight this to make sure that it is obvious. And then let's say that we only did the substitution method. We would take this verification step and place it right below here as well. Verification is the same, and maybe I'll make a note about that here. So just above here, I'll say verification is the same. There we go. Awesome. Okay, so here's our two methods, elimination and substitution. Now, sometimes when you get fractions in these examples like this, it can seem a little intimidating or seem like it's going to be a little more complicated than it is. Let's just quickly run through the steps of solving using elimination and substitution before we actually start tackling them in terms of linear quadratics and quadratic quadratics. So first and foremost, if we want to deal with the elimination method, we need to determine at least if one of the variables is the same. So whether the y's are the same or the x's are the same. If they're not the same, then what we want to do is we want to use the lowest common multiple or multiply both the equations such that they have the same coefficient for both equations for one of those variables. You then add or subtract the equations depending on if they're negative terms, positive terms, or a mixture. We then solve for the remaining variable once we've isolated a variable. Once we isolate that variable and we solve for it, then we substitute it back into the original equation, and it doesn't really matter which one you choose. Finally, you'll have an x and y in terms of an ordered pair. You write that solution and then verify the solution by plugging in that xy or multiple xy's into your original equations. Similarly with substitution, just slightly different, we want to isolate one of the variables right away. So we're going to pick one, preferably one with a coefficient of 1 to make it easier for ourselves, such as the one that we saw above. Once we isolate for that variable, what we're going to then do is substitute that value of that variable into the variable of the second equation, solve for the variable, substitute that isolated variable that you get, and then Lastly, write your solution and then verify it in the original equations. I would almost say step 5 and 6 should be swapped because realistically, you want to write your solution first and then just double check that it actually works for both of the equations there. Okay, now let's take a look at this in action here again. So we want to now shift to grade 11 because that previous example was a primary grade 10 example where it's linear. We now have linear quadratic, which means one of the graphs is linear, the other one is going to be a parabola shape or a quadratic. What we're going to do is we're going to do elimination first, then substitution, and we're going to follow the same method of we want to try and verify these things if possible or if we have the space. Now, for the linear quadratic system, what I realized right away is you want to make sure that your constant term is on one side and all your variables and x's, such as x and y and x squared, they should all be on the left-hand side. This is probably going to make it the easiest for elimination because all the terms will line up really nicely. Now, for substitution, it's a little bit different of a story, but for elimination, make sure it lines up really nicely like this, where you have constants on the right-hand side and all your variable terms on the left. Okay, now if we want to eliminate, what I notice right away about the equations is that I see a y and a y that are alone like this, and they're both a coefficient of 1, which actually makes our step of elimination quite easy. What we're going to do is we're going to rewrite those equations. 3x plus y is equal to 9. This is and it's negative 9, just to be very clear. This is our linear equation. Our quadratic equation is 4x squared minus x plus y, and then this is all equal to negative 9. So they actually equal to both. Negative 9 is a constant. All right, between these two equations, if I want to eliminate the y, because they're both the same sign, positive and positive, I must subtract. That's your number one indication. As soon as you see the same sign, subtract them. Now, when we subtract them, 0x squared minus 4x squared, that's negative 4x squared. There we go. 3x minus minus x, or 3x minus minus 1x, this actually becomes positive 4x. And then for our y's, y minus y is 0 y's. Negative 9 minus minus 9 gives us 0 for our constant. Because they're the same value, they actually wipe each other out. Now what we want to do is we see this, and we're like, okay, what do we got to do with this? Right away, you should be thinking, factor it. We're going back to unit 0. Factor, factor, factor. If you see a quadratic and you need specific x values, I think in class maybe, and sometimes this mistake can be made, is you would divide by 4 and divide by x as a way to kind of eliminate the terms or the greatest common factors, which actually is not a bad idea. You can remove a greatest common factor as the way to factor it, and in fact, that is probably the way we're going to do this. What is the greatest common factor for both these terms? They both share 1x and they both share 4. So what I'm going to do is I'm going to remove out negative 4 and an x, leaving me behind with x minus 1 in the interior. Because we see if we remove a negative up front, the middle term swaps. There we go, this is equal to 0. Now, from our quadratic equations unit, we would have taken both of these, that being negative 4x, and set it to 0. And we would have set our x minus 1 to 0. And let's just make sure that arrow is a little neater. There we go. Now, what we can do is we can isolate for the x's in both. We divide by negative 4 to get rid of that coefficient on x, leaving us with x is equal to 0. So x is equal to 0 is one of the solutions. If I add 1 to both sides on my second equation, this is going to become x is equal to positive 1. And if x is equal to positive 1 and x equals 0, that means there's potentially two solutions on this graph. And we're going to have to verify that in a second, but potentially this means we get two solutions. Now, remember, when we want to figure out what the y value is for both of these, because this is technically half a solution for both of these points, what we're going to do is we're going to take it and plug it in back to the original equation, and I would just choose the easier one. In this case, do you see how 3x plus y minus or equals negative 9 is the easier of the two equations we're given? Plug it into here and see what that y value is. So let's do that here. For step number 2, I'm going to go 3 times 0 plus y is equal to negative 9. This means that y is equal to negative 9. Hey, look at that. We get a solution right away. Easy as that. Our second solution, we're going to take this and go, well, it's going to be 3 times 1 plus y is equal to negative 9. If I subtract 3 from both sides, because 3 times 1 is just 3, this is going to give us that y is equal to negative 12. There we go. So here's our two solutions. We have y is negative or equal to negative 9, y equals negative 12. Now we want to put these as an ordered pair. Therefore, the two ordered pairs are going to be where x is 0 and y is negative 9. The other ordered pair was going to be when x is equal to 3 and y is equal to negative 12. Awesome. So we got 2 points out of this. That's exactly what we should be getting for this type of graph, especially when it factors to two different terms, namely a monomial and a binomial in this specific case. Now we're going to highlight this because these are our two solutions, but we got to verify them. Remember, we got to take these and plug them back into the original equations and see if it works. This might require a bit of room, so I'm going to try to make this as neat as possible. So to verify, what we're going to do is, first and foremost, I'm going to take that original equation, the 3x plus y equals -9, and sub in both of these. So it's 3 times 0, and then plus our -9 is equal to -9. Yes, this will wipe out. 3 times 0 is 0, -9 stays, and this is -9 equals -9. Hey, look at that, verified, perfect. That's one equation. The second equation was we had 4 times x, which actually, let's just make sure we get the right quadratic because we don't want to make a mistake here. 4x squared minus x plus y equals 9. So 4 times x squared plus the x value, and it's always good to just double check your signs. Yeah, minus x, so I should make sure this is a -0. And then plus the y value, which was -9, is supposedly equal to -9. Well, anything that's multiplied by 0 or that is 0 is gone. This means we're left with -9 equals -9. Hey, look, left-hand side equals right-hand side. Perfect, excellent, fantastic. And you know what? We're going to start adding that moving forward here. So what I'm going to do is I'm just going to shift this down a little bit. And below this, as soon as you see that left-hand side equals right-hand side, I want you to write that in because it's a very Math 30-1/diploma skill where we write LS equals RS, representing that the left-hand side of the equation equals the right-hand side of the equation, thus verifying it. Now, that was only for 1 point, so we know that 0 and -9 works. Now what we need to do is take these same two equations and then plug in the other point, which was 3 and -12. So what I'm going to do is I'm going to start by writing, well, we had for our first equation 3 times the 3 that was the x value, and then this is plus our -12, which represents the y. Supposedly this equals -9. This is our 9 minus, and I just want to make sure our x's and y's are all perfect here. Oh, our x is 1. Yeah, that's probably why it was. So I'm just going to backpedal this just a touch here. And I'm actually going to wipe this out here. I got to rewrite our solutions. So sometimes it's easy to make these mistakes here. First solution, 0 and -9. Our second solution was 1 and -12. There we go. There was probably some of you out there that were like, wait a minute, that doesn't line up. And even for me, right there, I was able to double check within our verification step that as soon as I started the verification, I was like, this doesn't seem like it's going to make sense. All right, now we have 3 times 1, which is equal to 3, minus 12, that's -9, equals -9. Therefore, the left-hand side equals the right-hand side, or LS equals RS. So again, if you ever see that LS equals RS, it means that we're telling us that we're comparing the two sides of the equation from the original equations. Now let's plug in that second solution to the other equation. This is going to be 4 times our 1 squared, and then minus the x value, which was 1. We're going to add our y value, which was -12, and then supposedly this is equal to -9. 1 squared is just 1. 4 times 1 is 4. Minus 1 is 3. And then if we do this, it's going to be 3 plus the -12 is supposedly equal to -9. Yes, 3 minus 12 is going to give us -9, which is equal to -9. And our LS, or left-hand side, equals our right-hand side. Perfect. There we go. It actually does work for both equations. We're happy. We're satisfied. All great. Now, again, what we're going to do, and actually before we move on, just make sure your solution is corrected. So we originally had a 3 here. Make that a 1 because our x value for our second case was actually 1, not 3. I think I was getting confused with the coefficient here. Okay, that was the elimination method. Substitution, again, we're going to borrow this verification in the very end because we know it's going to be the same verification, but what we need to look out for in the substitution is, do we get these 2 points that are the same? Because they should. In the end of this, we should get that they match entirely exactly the same terms. Okay, scrolling down here, using substitution now, what I'm going to do is I'm going to pick the easier of the equations to isolate a variable. In this case, I think it's this one. I see the coefficient being 1 here. I mean, we could do it for this one, but it probably makes more sense on the easier equation. I'm going to take this and rewrite it as 3x plus y is equal to -9. If I isolate for y, it must mean that I subtract 3x from both sides. So when I subtract 3 from both sides, I get y, and I'll just make that a touch neater there. Y is equal to negative 3x minus 9. All right, we have a y isolated. Now we're going to take all of this and plug it into the second equation. 4x squared minus x, and then plus, we're going to take all of the stuff that y is equal to, aka negative 3x minus y, and we're going to substitute that in for the y value. So we're going to write negative 3x minus 9, and then supposedly this is all equal to negative 9. Awesome. Okay, now we're going to combine the terms on the left-hand side. This is 4x squared. Negative x minus 3x is negative 4x. This is negative, or in this case, just negative 9. I'm going to just take that negative 9 right there. This is equal to negative 9. Now, we want to isolate x. To isolate x, what we could do is we could add 9 across, to technically, because realistically, we should be thinking about either this is going to be a trinomial or a binomial, depending on what happens, or I should say a trinomial, or yeah, I guess a binomial by 2 terms. I'm going to add the 9 across to both sides. Now, coincidentally, is when I add the 9 to both sides, I end up seeing that the term actually eliminates. So there's no constant, and this becomes 4x squared minus 4x is equal to 0. Hey, look, we've seen this one before. Now, what I'm going to do is I'm going to take this and I am going to eliminate the 4 and the x out front, or make them a GCF, not eliminate them. So I take this and I write 4x in brackets x minus 1 left behind is equal to 0. Now I take these independently. The 4x is equal to 0. I take the other factor, which was x minus 1, and set it to 0. And let's just make sure I take a second to make that a little neater. There we go. Perfect. Now I'm going to divide both sides by 4 on the left-hand side equation. When I divide both sides by 4, I get x is equal to 0. And then on my other side, if I add 1 to both sides, because I want to isolate the x, I'm going to end up getting x is equal to 1. Hey, look at that. We see the exact same things pop up again. X equals 1, x equals 0. Nice. We see the same factors that turn into the same zeros or solutions, so we're good with this. Now what we're going to do is we're going to take these and plug them into the 2 equations and solve for y, and then again, the verification step will just borrow from the elimination part. So starting off with the first equation, just to double check these numbers and make sure it's all good, we take it and we go 3 times 0, and then this was plus y, which is not 1, but plus y, which is the first piece. And actually, because we're not doing elimination method, we can actually take this and say, well, if we have these x values, take them and plug them back into the isolated y. So let's plug in 0 for x first in this equation, then y, and see what we get. Because we already isolated for the y, which kind of saves us a step here. So y is equal to in this term, negative 3x, or negative 3 times 0 minus 9. This gives us a first y value of negative 9, because anything times the 0 will just eliminate. Our second y value is going to be y is equal to negative 3 times 1, and then minus 9. This gives us negative 3 minus 9, which is negative 12. Hey, look at that. We get the same y values. Therefore, our solutions right below, we can write first and foremost, when x was 0, we got an output or a y value of 9. When our x value was 1, we got an output value of negative 12. We get the exact same solutions whether we use substitution or elimination. And then lastly, I can just say, hey, you know what? We've had this verification from our other side here. The verification step is the exact same. So we're going to say that perfect, as long as we know that the numbers work out the same for the x and y's, this is perfect for us. So I'm just going to write it as the verification step is the same. Awesome. Now, substitution or elimination. If they just ask you blankly, algebraically solve, you choose which way you want to go and just go with the one that you feel more comfortable with. That's my recommendation on these. Now, if they ever specify, you're going to have to use one method or the other. So it is important to know both. However, you always will have the option, if it purely just says this keyword up at the top, solve it algebraically. Now, in this case, they had the 2 bubbles where we had to solve them both just so you can see them both. Now, to verify these solutions graphically, as we remember from our previous lesson, or 8.1, what we had to do is, in order to type these into a graphing calculator, both of them must be isolated for y. So I'm going to start off with the first equation and make sure we have this in terms of y. To do that, it's actually from our substitution step. We subtracted 3x from both sides. When we subtracted 3x from both sides, it gave us an equation that we can type in, y1 is equal to negative 3x and then minus 9. Now for our y number 2, or y2, in the equation that we have above here, we see that we have 4x squared minus x plus y minus 9. I'm going to take all of this and move it over to the right-hand side. Because if this y is already positive, let's keep it positive on the left-hand side. I'm going to move my 4x and my x over to the other side. So my term is going to become the following. Negative 4x squared and then plus x minus 9, because we've brought all the terms over from the other side. Okay, now that you've typed these in graphically, and which we'll do in just a second, or now that you have them in terms of y, we can type them in graphically. I'm just going to move this slightly over. We're going to go into our y equals, or on your Casio, you're going to go into your graph mode from your menu. We're going to start by typing in negative 3x minus 9 into the first. Into y2, we're going to go negative 4x squared plus x, and then minus 9, graph it. Now, you probably realize that the window settings aren't fantastic. What we can do is we can actually lower it so that instead of the y max being at 10, maybe we make the windows so that the y max is something like, let's say 0, because realistically it looked like everything was below. Now, this is me having it where the y value or the y maximum was 0, so it's right at the x-axis for the top value. As you can see with my calculator, it's all nice. I can just zoom into it. For yours, you're going to have to play around with your window settings a little bit because you won't have that ability to zoom. What you see is that there's 2 intersection points, one at that y-intercept, one that is somewhere at 1, and it looks to be negative 12. From our standpoint, this looks fantastic. This is great, because if we're getting something that's like this, this is excellent. Now, I'm just going to provide a very rough sketch of what this looks like over on our side here. So let's say that this is the axis up here, or x-axis up top. Let's say it goes right down the middle like it does here. What I'm going to do is I'm going to sketch out that first graph very quickly here. So let's say I draw it in red, which is the quadratic. It kind of comes up like this. It cuts through a value, and I'm going to make this a little narrower because it seems to be very narrow. Cuts through, reaches a maximum, and then comes back down. Perfect. We'll put arrows on the end because we don't know how far this is going. Now the linear line, which I'm going to draw in blue, comes down from left to right in terms of it's higher on the left, goes down to right. It's a negative slope, which is confirmed by the fact that it's negative 3. I'm going to have it cut through at this specific point, which is our y-intercept. It then comes down and cuts through about here. So this is a very rough approximate of the graph, of course. You want to get as accurate as possible with these things, but there they are. Perfect. And I'll even color code these. Here's your y1. Here's your y2. Awesome. The solutions are here. The solutions are here. In your graphing calculator, this one will end up being the 1 and negative 12 that we solved. The other one, which is up here, will end up being our 0 and negative 9. Now, again, this is not a very good graph because it's really off by scale. If you look at this, we have a lot of white space on the top here, but just very roughly, this does give you a depiction of what this looks like. So realistically, even though this isn't the perfect sketch of this, hopefully it just provides enough where it's like, hey, this is the rough idea of it, and that's perfect for us. Now, just to give you some written instructions of how we solve these here, if we want to solve these in our calculators, first and foremost, in the TI calculator, if I want to solve for intersections, I go second, trace, and then intersect. If I want to solve on the Casio, I'm going to go shift, G-solve, and then intersect. Perfect. And I think they actually use it in this way, intersect as such. Perfect. And I'll even underline this here. Excellent. Fix this one just a tad, just to make sure it's neat for our notes. There we go. Okay. This is how you would solve it for both calculators. Awesome. Again, not the best picture, but at least it will do the trick for us. All right, solve the system of equations by substitution. Okay, here's where they specify it. So if they don't specify, remember, you can choose if they just say algebraically, but in the case they specify, we must follow the method. So for substitution, really beautifully, if you look at this, we have a linear system here, or a linear equation, sorry. The top one is going to be a quadratic equation. When we have these, these different equations, what we can do is we can set them up in terms of, for substitution, one of them has to have an isolated variable. The beautiful thing about this one, the y is already isolated here. So if that y is isolated, what we're going to do is we're going to take all of what y is equal to and plug it in for the y in the second equation. So let's start by doing that here. If we know that the y is equal to this negative 2x squared plus 10, then for the second equation, or for part number 1, I'm going to write the following. This is x minus 2 times everything y is equal to, which is 2x squared plus 10. This is all equal to, well, in this case, it's actually just equal to that piece here. So I'm going to have this over on the, equals to 15. I was like, wait a minute, we don't have a value here. We're plugging into the second equation. There it is. Awesome. Okay, from here, what we're going to do is we're going to write this as x plus 4x squared, because negative 2 times negative 2 is positive. Negative 2 times 10 is negative 20, which is equal to negative 15. Just going to do a little rearrangement here. So I'm going to move my 4x squared in front. I'm then going to have the x in the middle by descending order. Then the negative 20 is equal to negative 15. We don't want the 15 on the other side. As soon as we see that it might become a quadratic, please just add it to both sides, because what we want to do is either factor it or use one of our algebraic methods from quadratic equations to solve this. This is going to give us 4x squared plus x. Negative 20 plus 15 is negative 5, which is equal to 0. Now we have it in a trinomial. Let's factor this. This goes back right to unit 0, or chapter 4, which was quadratic equations. We need two numbers that will multiply to make the 4 times negative 5, which is negative 20. We need two numbers that will add to make 1. That means it's going to be 5 and negative 4. You multiply those two things together, you get negative 20. You add them together, you get that positive 1. Now, we unfortunately can't just do inspection because the a value, or this value, is more than 1. So what we're going to do is we're going to rewrite this as 4x squared plus, and actually, let's put the 4 first. The reason I'm going to put the 4 first is I like the fact that there's 4 and 4, and then there's going to be 5 and 5. There we go, because order does not matter in terms of the way you plug in those two numbers that add to make the middle number. Now we're going to factor this by grouping. Remember, if you see a 4-term polynomial, what you want to do is you want to make sure that you factor it by grouping. I'm going to remove a 4 and an x, leaving me behind with x minus 1. For my second grouping, I'm going to pull out a 5, leaving me behind with x minus 1 is equal to 0. Now I'm going to pair together the outside terms, 4x plus 5. I'm going to take one of the common binomial and write it together. There we go. This is equal to 0. Now what we can do is we can take the two different binomials and make them equal to 0 on their own. To do that, let's actually just do that up over here on the right-hand side. Step number 2, once we have those common factors like that, we're going to write it as, and just to clean that up a tad, there we go. It's going to be the 4x plus 5, and maybe I'll drop it with the brackets here. 4x plus 5 is equal to 0. Now that it's set to 0, we're going to subtract 5 from both sides. There we go. This gives us 4x is equal to negative 5. We divide both sides by the 4 in order to isolate x. And now we're going to have where x is equal to negative 5 over 4. There we go. Okay, there's our first x value. Our second x value is going to come from when we plug or take our second binomial and isolate it. So now we have x minus 1 is equal to 0. This one's a lot simpler. We're just going to add 1 to both sides. And again, I'll try to be as neat as possible with these things. Add 1 and add 1. X is going to be equal to the positive 1. There we go. So now we have our two x values. In order to get our y values, we need to plug it into one of the original equations. I think the easiest one to plug it into is going to be this one, because it's already isolated in terms of y, which is beautiful for us. Okay, now if we want to plug it into that first one, let's take a second to do that here. What's going to be our best spot? Probably over here on the right-hand side. All right, so plugging in these x values, what we're going to do is we're going to go 3 and then circle it, or step number 3, and I'm going to take it and plug it into that original equation. This is going to become y is equal to negative 2 times the negative 5 over 4, all squared, and then this is going to be plus 10 on the outside. Now, let's just bring out our calculator here. We're going to type in exactly what we see here. So it was negative 2, and then in brackets, I'm going to create a fraction. This is 5 over 4. On the outside, we're going to square it all, and then we're going to add 10 to this. It gives us 6.875 math fraction. We're going to get 55 over 8. So from here, our first solution in terms of a y value is 55 over 8 as a positive value. Now for our second one, it's going to be y is equal to negative 2 times the 1 for the x value squared plus 10. This gives us y is equal to positive 8. Excellent. So now let's put these as ordered pairs. For the first one, it's going to be where x is equal to negative 5 over 4, and the y value was 55 over 8. There we go. And let's just try and clean it up just a tad. There we go. Our second solution was where x was equal to 1 and y was equal to 8. Awesome. So let's make sure we highlight this, representing that this was the two solutions that we should get. Now, there's not a lot of room to work with on this front page, right? So to verify the solution, what we're going to do is we're just going to take these and plug them in on the next page. What I've actually done is written out those two equations that we get from our previous page, and then I've just rewritten them here. When we do our verification step, we're going to plug in both the points to both the equations. Starting off with the first one, if I write verify, just like we've done in the previous problems here, I'm going to underline that. We're going to take the y, which is 55 over 8 for our first solution, is equal to the negative 2 times the negative 5 over 4, all squared, plus 10. Well, what we're going to notice is that these two are actually equal to each other. So 55 divided by 8 is equal to the 55 over 8 on the left-hand side. So the left-hand side equals the right-hand side. Excellent. There we go. We verified that it works for the first equation. Now what we got to do is verify it for the second equation. When we plug in the x value here, this is going to be x is negative 5 over 4. Then for our second piece here, it's negative 2y, or 2 times the 55 over 8 is equal to negative 15. Now what we're going to do from here is we're just going to type this into the calculator just to make sure it's all good. So I'm going to go negative the fraction 5 over 4, which is our x value. We're going to go minus 2 in brackets, fraction 55 over 8. And then supposedly when we enter this, we should get negative 15. In this case, we do. So we get negative 15 is equal to negative 15, which means our left-hand side is equal to our right-hand side. Really important that we're showing left-hand side equals right-hand side just to make sure it works. Now, this is one step. We verified the one answer. We got to verify both answers. So I'm going to take the second point, which was 1 and 8, and plug them into both equations. So starting off with our first equation, it was y, or 8, is equal to, we have our negative 2x, which is negative 2 times 1 squared plus 10. This gives us 8 is equal to 8, or the left-hand side is equal to the right-hand side. For the next equation, what we're going to do is we're going to plug in our 8 to the y. So for our second one, it was x, which is 1, minus 2 times the 8, which is our y, is supposedly equal to negative 15. 1 minus 2 times 8, which is 16. 1 minus 16 is equal to negative 15, which is equal to negative 15. The left-hand side is equal to the right-hand side. Hey, look, we verified that it works for both equations. Fantastic. This is what we needed to show, that it satisfies both equations for both points. Okay, so both points are valid, which isn't always the case, but in this case, it does work out very well. All right, let's flip back and do elimination on our second one here. So for example 3, use specifically elimination. Again, if it just said algebraically, you get to pick, but for this one, it says specifically by elimination. What I'm going to do is I'm going to look at these two equations side by side and be like, is there a variable I can eliminate right away? In this case, I don't have to multiply them because I see a negative y and a negative y. So what we're going to do is we're going to rewrite these out here. Starting with the first equation, I have 6x squared minus x minus y is equal to, on the other side, negative 1. And then we have 4x squared minus 4x minus y is equal to negative 6. Now, something I want you to realize about this is that all of the x terms and y terms are on the left-hand side. All of the constants are on the right. This is a really good way to organize it when you eliminate. Now, if the signs of y are the exact same, they're both negative and negative, what we're going to do is we're going to subtract. If the signs are both positive or both negative, always subtract. If they're different, you can add. 6 minus 4x is equal to 2x squared. We then have negative x minus minus 4, that's plus x, that's going to give us plus 3x. Negative y minus y is going to be 0 because they eliminate each other. And then negative 1 minus minus 6 is going to be equal to the positive 5 down here. Now, again, we want to make this into a quadratic. To make this into a quadratic equation, we must subtract 5 from both sides because we're probably going to end up factoring this. It's 2x squared plus 3x minus 5 is equal to 0. Now, for this one, we're going to look at this and think about our options. We can put it into quad formula, we can factor it, we can complete the square and then do the square root principle. Those are all options at our disposal. For this one, I'm just going to take a look at it and be like, well, first of all, if we have to multiply to make 2 times negative 5, that's negative 10, and we have to add to make 3, this is definitely doable with the numbers. So what we're going to do is we're going to factor this. It's not always possible, especially if you can't think of numbers off the top of your head. I would go to quad formula. That would be my recommendation. If you can't think of numbers right away, use quad formula. Or if the numbers are simple like this, you could complete the square. But factoring is obviously the one you want to check first, because if you can do it, it's nice. So this is going to give us 5 and negative 2 for the numbers. Again, we have an a value that is greater than 1, so we must use decomposition. 2x squared minus 2x plus 5x minus 5 is equal to 0. We see 4 terms in the polynomial. I'm going to underline the first 2, underline the second 2. In my first grouping, it's 2x that's common, leaving me with x minus 1. I see 5 is common, leaving me with x minus 1 in the bracket here. Now what we're going to do is create the common binomial, or the outside terms together, then one of the common binomials. There we go. There's our factored terms. Now what we want to do is take each of these binomials and separate them onto their own. When we separate them onto their own, we're going to get where we have 2x plus 5 is equal to 0. And our second binomial was x minus 1 is equal to 0. Isolating these both for x, we're going to start by subtracting 5 from the left and the right. This gives me 2x is equal to negative 5. I'm going to divide both sides by 2. Therefore, my first x that I'm going to get is equal to negative 5 over 2. My second one, it's very easy. I'm just going to add 1 to both sides. When I add 1 to both sides, I get x is equal to positive 1. Now, I have 2 different x values here. So what I'm going to do is now take these x values and then plug them into one of the original equations, because unlike substitution, we don't just have that isolated variable that we can plug in. Now we just got to choose. The more simple of the 2 equations is probably this one, just because like when you look at the numeric coefficients, there's 1, 1, and 1, whereas this one's 4, 4, and 6. I just choose the nicer one, which is the top one here. So starting off with our first x value, we're going to take this and go, well, it's 6 times the negative 5 over 2 all squared. Just to make sure I get my signs right, minus x, which is minus negative 5 over 2. And I want to make sure that negative is visible. There we go. And then for our other term, it's going to be minus y, which is our term we're looking for, which is equal to, from our other side, negative 1. Okay, now in order to get the y isolated, what we could do is we could actually just swap these two. If I add y to both sides as such, and then I add 1 to both sides, this will actually change those two in terms of their position and give me where y is equal to the 6 times negative 5 over 2 all squared. And then minus minus, I'm just going to change this to a positive 5 over 2 plus 1. There we go. Now this is something we can enter to our calculator here. So 6 times the fraction of 5 over 2 all squared. And if you're wondering why I'm leaving out the negative, it's because when you square a negative, it becomes positive, plus 5 over 2 plus 1. There we go. So we end up getting that our y is equal to 41. There we go. So that's our first one. For our second one, what we're going to have to do is the exact same work, but just with the x equals 1 instead. This one's hopefully a lot nicer. But what I'm going to do is I'm actually going to borrow this from above. And no, we could show this algebra, so I'm not going to be skipping steps here. If we go 6 times 1 squared, and then minus the 1 that goes in the brackets here for x, and then minus y is equal to negative 1. I'm going to swap those just like I did before, so plus y and plus y. I'm going to add 1 to both sides, like so. This is going to give me y is equal to 6 times 1 squared. This is just 6 minus 1 plus 1. We get a y value, which is equal to 5 plus 1, which is 6. There we go. Now, we actually have 2 solutions here, and we need to make sure they're both present for this situation. So I'm going to go maybe up to the top right to represent it. Therefore, for my first solution, we're going to write negative 5 over 2, which was the x value. The y value was 41. For our second one, it was x value is 1, y value is 6. Close it off, highlight these as the solutions. Perfect. Now, we think these are the solutions for the most part, right? Like we want to assume that these would probably end up being the solutions if we can verify them, but that's the piece, is we want to make sure that we do verify them, which is exactly what the instructions ask for, is the verification. Okay, because of limited space, again, what we're going to do is we're going to take these original two equations, write them on the next page, and then verify them into both the equations here. Okay, I'm going to take the first equation, and I'm just going to make sure I write it. So 6x squared minus x minus y. Let's make sure I got that here. 6x squared minus x minus y is equal to negative 1. My next equation was 4x squared minus 4x minus y was equal to, and then on the right-hand side, it was negative 6. Perfect. There we go. Now, in systems, typically what we see is that there's this bracket just representing that it's the collection of these together. Now, for the first term, what we had is we're going to do our first one, which was 6 times the negative 5 over 2 all squared minus the 5 over 2, negative 5 over 2 that is, minus the y value, which was 41, is supposedly equal to negative 1. Well, in fact, this is the one that we double checked that was 41. So this should give us the negative 1 is equal to negative 1. Because when we evaluated this, we figured out that the y value that we plug into here was actually equal to 41. So left-hand side equals right-hand side. This should work for us. Now, let's just double check on the calculator. It's always a good idea. So 6 times the fraction of 5 over 2 squared. Again, I'm going to not leave in the negative because I know when I square a negative, it becomes positive. I'm going to add the fraction of 5 over 2 because the double negative. And then I'm going to subtract 41 from both of these, and it should give me negative 1. Excellent. Okay, let's plug in these x and y's into the second equation. So in my second equation, we get 4 times the x squared, which is negative 5 over 2, all squared, minus the x value again. And I just want to make sure, oh, it's going to be 4x. Yeah, it's important to get the 4 there. So 4 times the negative 5 over 2. And then we're going to have our minus y, which again is negative or minus 41 like this, is equal to, on our other side, is negative 6. In our calculator, let's just take a second to plug this in. We're going to get our 4 times, in brackets, the 5 over 2 all squared minus 4. Whoops, let's make sure I clear that out because it started turning into a bit of a cluster of terms. 5 over 2 outside the bracket all squared minus 4. We have a bracket of alpha 5 over 2. Close the bracket, and then minus 41. There we go. And I am forgetting the negative that is up top, but actually no, this should be a positive between these two because the double negative. There we go. So this gives us negative 6 is equal to negative 6. And therefore, the left-hand side is equal to the right-hand side. Awesome. Okay, let's do what we did in the one above here, where we want to confirm that the other solution of 1 and 8 works for these two, or in this situation, 1 and 6, my bad. So if 1 and 6 is the other solution, then what I'm going to do is I'm going to take that and plug them into both the equations. Starting off with the first equation, we have 6 times 1, which is the x value squared, minus that x value, which is 1, and then minus the y value, which was 6, is equal to negative 1. 6 times 1 squared is just 1. 6 minus 1 is equal to negative 5, or sorry, positive 5. Positive 5 minus 6 is negative 1. Therefore, negative 1 equals negative 1. Our left-hand side equals right-hand side. Excellent. Confirmed. Next equation, we go down to the one that is 4x squared. So 4 times 1 squared minus our 4 times 1, which is the x. Then from there, it was minus our y value, or minus 6, is equal to negative 6. 4 times 1 is just 4,
4 minus 4 is 0. Negative 6 equals negative 6 from both of these two. So therefore, the left-hand side equals the right-hand side. Awesome. So it's really important that when we're verifying these things, that we're plugging them all in for the original equations, and we're making sure that we're showing that both of the original equations satisfy for both points. Awesome. Lastly, for this lesson, we're going to look at example 4, and we're going to write a systems of equations that can represent each of the graphs below, and then verify it just with the graph, because on the graph, we can see how many solutions there are. First and foremost, I see two solutions that I just want to make sure we point out right away. First solution is right here. This is our crossover point. It occurs at the x value of 2 and the y value of negative 1. The other equation, or the other intercept, I should say, is where it crosses at 7 for x, and then in terms of y value, it looks to be negative 6. All right, so accordingly, our equations should give us these solutions. Now, to get our equations from here, what we have to do is we have to figure out, when we look at these two, to get our solution for our different equations, if it's a linear line, we know linear lines have the following form. We know they're y equals mx plus b. So we're going to have to figure out for the first equation, if it's y equals mx plus b, where the m value is the slope, and let's make sure I have a different color here. If this is the slope, and then this is the y-intercept, then it must be that we need to figure out those two values. First and foremost, the y-intercept is right here at 1. So 0, 1 represents the b value. For our slope, it can be between any 2 points. I'm going to go maybe down from this one here and then over to this point here. If we do that, we're going to go from 1 to negative 1, which is down 2 or negative 2. And then to go over, we go from 0 to 2, we go over 2, meaning the slope is equal to the rise, which is negative 2, over the run, which is 2. This gives us a negative 1 slope. So for the first equation, we know that it's going to be y is equal to negative 1x, and then plus the 1 for our y-intercept. Now, to get the quadratic equation for the parabola, what we're going to have to look at is the vertex is up here. This is at positive 4, so 4, and it looks to be 3 on the other side. I know it's a little bit blurry for us. And then we can use either one of these other 2 points to help us out. So we always know that we're missing the a value on these things. So I'm going to start by writing out the original equation. Y is equal to a x minus p all squared plus q. From here, I'm going to plug in my y value, which I'm going to choose the 2 and negative 1 to help us out. Negative 1 is equal to a, 2 for x. The p value was at positive 4, which means it's actually negative 4 in the bracket, plus the q value, which was at 3. This is going to give me negative 1 is equal to a. 2 minus 4 is negative 2 squared is 4 plus 3. When I subtract 3 from both sides, and I'm going to make that 3 just a bit better there. There we go. This is going to give me negative 4 is equal to a 4. And thus, when I divide both sides by the 4, I'm just going to get a is equal to negative 1, which that just means that the graph, or the original graph, faces downwards in this situation. Now, just to make sure this is all good, because it does look maybe a touch wider potentially, I want to look at this and be like, let's say we look at our points. We have it at 2 and negative 1. Yeah, that looks okay. It's 7 and what looks to be negative 6. Yeah, and I'm just going to count down just to make sure. So this is 1, 2, 3, 4, 5, and 6, and the 6 is across here. So yeah, that works for us. And then for the 2 and negative 1, when we plug them in, we had 2 at x, negative 1 for y. Excellent. We had negative 4 in the brackets there, which is our 2 minus 4, which is negative 2 squared is 4. Yeah, this seems to be good for us. Okay, now what we're going to do is we're just going to state our system of equations, the system that goes with this here, and maybe I should even just like sandwich this just a little bit over so that we can put it together here. Might have to just redo that there. There we go. Move this one over. Awesome. I'm going to make the system of equations and say, therefore, we say that our first equation is y is equal to negative x and then plus 1. Our second equation is y is equal to the a value, which is negative. We don't really need to put the 1 there. X minus 4 squared and then plus 3. Now, in order to verify this, you would just simply plug in these intercepts. So the 2 and negative 1 and the 7 and negative 6, you would plug these in and then solve from there to see what your if it actually satisfied for both, which I'm not going to do on this lesson video. I'm just going to leave that for you. All I was curious to do was just make sure we could build out our equations. For this next one, I just want you to look at this and be like, will there ever be a crossover? And most of you should say no, because what's going to happen is that there is no solutions, and I'm not even going to worry about building out the equations. There is no solutions the inside A of the inner graph is greater than the outer graph. And if we know that this is the case, where it's the outer graph, in this case, and let's just make sure, there we go, perfect. So if we know that the a value of the inner graph is greater than the outer graph, then the inner graph will grow at a faster rate than in terms of their y values, than the outer graph, and they'll never actually cross each other. So no solutions. And even if we came up with the equations, what you would find is that they would have those different a values, so therefore never cross. All right, here's where I want you to go into your assignment and then try out these problems for yourself.